Okay, let's go ahead and get started, everybody. Hi. How are you doing today? How was your weekend? All right, next class we'll have a midterm. You should have seen notes. I posted notes on that social media thing that we use, Blackboard, about the midterm. Did you all see them? Everybody happy with them? Any questions about the notes? Yes, sir. Okay, there's an error in the notes. I talk in one part about getLine operating in conjunction with the angle operator. I pointed it the wrong way, like I always do. We'll talk about vectors today, by the way. We'll get to them. They won't be heavily emphasized on the exam, probably. Okay. So there was an error in the notes. It's not getLine with the output operator. It's actually getLine with the input operator. Okay. So when you see the thing in the notes about the angle operator operating in conjunction with getLine, it should be the input operator, not the output operator. That being said, any questions about the midterm? Great. Moving. Oh, yes, sir. On the notes, I said one of the topics was getLine operating in conjunction with the output operator. It should be the input operator instead. That was, I told you, the things I mess up in this class are greater than or less than signs. I do it all the time. I do it all the time in my own code too. It's horrible. Yes? Yeah, I've been thinking about it. I'll at least post some practice questions. If you do me the favor of shooting me an email to remind me, I will either post an exam or some sample questions today. Okay. Yes? The single most useful thing you can do to study for the exam. Come to class every day. I mean, the exam, you've seen the type of code we write in class, right? The questions on the exam will be similar to things that we've done in class as the class examples. One of the things you might do is look at all the code that I've posted that we've written in class and read it to make sure you understand how it works, so that if you're given a similar piece of code, you're able to predict how it works. That's probably the single most useful thing to do. And like I said in there, it's useful to have somebody to study with, right? I don't know if you all have made friends with each other in class, but I have found throughout my computer science career, particularly when I was in graduate school, I had a really good friend. We went through like pretty much every single class we took together, and every exam we would study together. And having somebody to study with helps an awful lot. It really does. So, form a study group. Just find somebody who you think is much smarter than you, and, not me, though. I'm not taking the exam. Also, I'm not smarter than most of you. So I just have, at this point, like a 30-year head start. So, other questions? This is surprisingly few questions for right before the midterm. So either I've done a really good job, or a very bad job. Yes? Identifier is the name of a variable or a constant or a function. Sorry, I might have missed saying that in class. An expression is anything in C++ that evaluates to a type and a value. So if we just say, like, if we have an int I which is equal to 6 and we say I, the expression is what that thing turns into in terms of the value. So if we just have I, it's whatever value is stored in memory. If we have a function can be an expression, and it's whatever value comes back from the function through return. Does that make sense? Do you have a question too? Yeah. Okay. Yes, sir. A literal is the value that you can set a particular type to. So for example, an integer literal would be a whole number, 1, 2, 3, 4, 5, 6, 0, minus 1, right? A real would be any decimal number. It would be 1.0, 2.0, 0.0, something like that. A character literal would be a single letter inside single quotes. A string literal would be a string of letters inside double quotes. A bool would be either true or false. Those are pretty much all the literals that we need to know about. We just have the exam right now if you're all ready. Should I get it out? Yes? Yeah, it'll be something like, I'll give you a specification like I did for project 2, and I'll say, write this program, just write it all out on your paper. No, it won't be like project 2. It'll be something really small. This is the best part of the class for me, is messing with you all. No, it'll be something small. It'll be like, write a program that, given a string, tells you what all the vowels in the string are. Right? That would be like a hard one. That would be a pretty hard one for the class. And I would expect you to input a string, use a for loop to use at, and then have a switch statement to see if like the thing you were looking at was a vowel or not. Does that make sense? So small programs like that. Yes? Uh-huh. So there's also so the equal sign is assignment operators, but we've also seen assignment operators like plus equals, minus equals, division equals, star equals. Mod equals might work too. But these are also assignment because they do math and assignment at the same time. And then, I mean, plus plus and minus minus I wouldn't call an assignment operator, I would call them an incrementer, but they also end up assigning a value. No one else? Do you want to go ahead and talk about some new stuff? Yes? Yeah. There's only like 4 or 5 different sizes and shapes, so there's not that many. Yes? Uh-huh. So whatever I give you in class is going to be small enough for you to do in exam time. Does that make sense? So like when you write a project outside of class and you have 2 weeks to do it, essentially, you have a lot of time to implement the stuff for error checking and things like that. In class, I'm not going to ask you to write a program that the same size program that I would give you 2 weeks for, because you're going to have like 12 minutes for it, right? Does that make sense? So if I give you something, I'm probably not going to say, I might say like, count a valid program for this class might be count how many lines there are in a file and check to make sure you open the file correctly. And I would expect you to be able to say ifstream input file.open whatever name, if not input file. And that error checking I would expect you to do. And then the reading the file would be a very small part of it, right? I wouldn't expect you to say, draw a flowchart for how to do the Framingham calculation because it's got 18 billion steps and there's no way you could do that in a few minutes. So they're going to be relatively small. There were, at the bottom of the note I sent out, there were some sample programs. So those are about the size and scale that I would expect for the class. I'm sorry, for the midterm. Yes, sir. What are all the sections of the test? No, I haven't written it yet, so I don't know. I tend not to write it until the morning of the exam. Why are you all laughing? That way it can't be stolen. Nobody can break into my office and steal an exam I haven't written. So it's fair. I'll try and be in a good mood on Thursday. So yeah, so I'm paranoid, and my way of keeping my exams from leaking is not to write them until right before the exam. So works for me. I don't know why you're all shaking your head. So that, and I can see what questions I get asked in class, and then I can write questions about things I wasn't asked about, on the assumption that you know those better since you didn't ask about them, right? You should ask about everything. That would be wise. Other questions? But really, most of the exam, the bulk of the exam will be, last semester exam, there was one question that was essentially true-false, but you had to fix things. I gave you some code, and I was like, does this line of code have any compiler errors in it? And if so, fix them. That was like one of the questions. I had a bunch of questions that were, tell me what this program outputs, and that was the bulk of them. And then I had one question that was like, write code that does something. I don't remember what it did, but it's one of the small things that we're talking about. So, in fact, if you're, I mean, if you're practiced at going through and stepping through code and reading what it does, you can knock out the exam probably in like 15 or 20 minutes. Another thing about my exams, on average, women do better than men. True story. All right, other questions? No pressure. I'm just saying that's statistically what's happened. Yes. You will have the whole class for the exam. Some people might be able to finish it in 20 minutes. You might be one of those people. And the people who finish in 20 minutes also sometimes pass. So, so anybody can finish it in 20 minutes, but just depends if you practice reading code and seeing what it does. It's relatively straightforward. I've been trying to emphasize that by drawing like the pictures on the board, showing you how I do it, by emphasizing that you just be dumb, right? Like the computer, be dumb, start, next line, next line, next line, just grind along. Yep. 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 You might. Nope. I mean, if I ask you to write code and you use a string, then I will check. I mean, the ultimate arbiter of whether the program you write on the exam is right or not, like if you come to me and complain, we're going to type it into the computer and try and run it. Okay? Pretty simple. Anything else? Going. How many of y'all are nervous? How many of y'all will be more nervous on Thursday? Okay, normal. All right, last time we finished up our very lengthy discussion of function parameters by talking about constant parameters. What do we use constant parameters for? Yes? Yep. Exactly. Constant parameters keep things inside a function from being altered. The most important use they have is when you're passing very large chunks of data around, which we haven't done yet, but we will. And you want to make sure that you don't have to make a copy of this large chunk of data, but you don't want it to be changed. Okay? And we talked about default parameters. What are these for? Yes? Yes, if one of the parameters is not specified, it will resort to the default parameter. The default parameter always has to be the rightmost parameter, or all the default parameters have to be the rightmost parameters. Right? So you can't choose which ones, it always has to be the rightmost. These mostly exist, they have occasional uses, but they mostly exist for confusing students on exams. Okay. All right, so that's what we talked about last week. Now that we're all in a nice, grim, stressful mood facing the midterm, let's have a party. How many of you want to have a party? All right, so we're going to have a party. And here's what we're going to do. We're going to make a list of people that we want to invite to the party. How's that sound? What? Why are you all looking at me like I'm crazy? I mean, I am crazy. I just don't know why you're looking at me like that. So let's, where did I go? What's going on here? Let's look at our party list. So here I typed up a list of people to invite to our party. So pretty much Justin Bieber and One Direction, because I understand that's really popular with you guys today. No? All right. Well, here's our list of people that we want to invite to a party. And if we read this list of people from a file, we know what to do, right? You know how to read lines from a file one at a time, and you can do something with each line as you're processing it. Is that correct? You all should be nodding. How about this? How about we want to read a list of stuff from a file, and we want to have the whole list to work with when we're done, right? Because right now, as we loop over the file, we get each line one time, and we get to do something with that line while we have it, right? And then we go on to the next line, and what happened to the line before? It's gone, right? What we've seen is how to process something line at a time, but what we haven't seen is how to keep a collection of things together. Does that make sense? So, what we might choose to do, if we want to have a party, is we could define like a variable for each person who's going to come. So here's our party. This is the file party.cc. And what we could do, and I'm going to need strings for this because we're dealing with strings. You all aren't as excited about this party as I am, I don't think. Here's what we can do. We can have string guest 1, guest 2, guest 3. How many guests are we going to have? Are you sure? Are they all going to be able to make it once we invite them? These guys seem pretty big shots. Do you think they might bring an entourage as well? Like other people along? Okay, so what's the problem with doing it this way then? Where we have a variable for each individual guest. Yes? We don't know how many guests there are going to be. And here's the other thing. Let's say it's going to be a really, really big party, right? Like, I don't know, somebody name a really, really big party. Times Square ball dropping, that's fine. Now this year Times Square ball dropping is by invitation only, and we have to keep an invitation list of everybody, and there's going to be how many people there? A million? All right, well I better get busy, right? Guest 4, if I'm going to go all the way to a million, I have a lot of typing to do. So this clearly isn't going to work, is it? It's not going to work. This is a bad idea. And we don't have a better idea yet. And the reason is because we haven't taught you how to handle this. And this is what we're going to deal with. So let me make an analogy. How many of you have ever bought drinks at a store? Like you bought Cokes or something like that. And when you go, how many do you get? You just get one? You're going to bring them back to your room to keep them for around. How many do you buy? Case Gatorade 2? You buy 2? Anybody ever buy more than 2? Yeah, you buy like 20 or 30. And when you go there to the store, do you actually go up to the shelf and you're like, oh, 1 can, 2 can, 3 cans, and you start putting them in your shirt, 4 can, 5 can, and you just get more and more of them? Is that what you do? What do? You put them in something, right? You have a container, and you put all these things into a container, and then instead of having to carry 20 or 30 or 50 different things around, you just carry one container that has everything inside it. Does that make sense? Okay. In most computer languages, including C++, there are things that are considered containers. And they are things that you can put other data inside and carry them around. And the simplest of these is called a vector. A vector. And what a vector is, it's just a collection of a whole bunch of things that has a bunch of entries. The vector itself has a name, so we can declare a vector of, I don't know, we'll call it guests. And we have to tell the vector what type of thing it's holding. Okay? So this would be like a string. So we'd have vector string of guests. Now, how many guests are in there? We don't necessarily know right now. There may not be any. So let's go ahead and do some coding for this. So instead of trying to have an insane number of variables, I will just go ahead and comment out. We're going to have the good way of doing it. And here's what we do. In order to use vectors, which is a collection of things, you have to say pound include, guess what? Vector. And in order to declare a vector, you just say vector. And then you have these angle brackets. The angle brackets tell you, essentially say what's going to be in there. So the way to declare a vector is a vector, angle bracket, what type is going to be there, and then the name. So this is just like declaring any other vector, any other variable, except instead of just saying what type it is, we say it's a vector and what type. Now we have a container, and the container guests will hold many different strings inside of it. Does that make sense? Everybody with me so far? Yes, sir. Vectors are, yes, they are not of a fixed length. We'll get to that shortly. You can say how big they are if you want, but we'll get to more of the details shortly, okay? So here we have our vector of guests. And this is a vector of string of guests. And now we can do some of the other stuff we want in order to read from the file. Pound include fstream. And yeah, might as well read it from a file since I already have the file here, right? These people aren't really popular with you? ifstream input. Let's look at my notes for a second, decide what we're going to do here. And here I'm just going to cheat and do like kind of a shorthand for opening a file. ifstream input party.text. This is the same as doing ifstream open. And we can just check and make sure this worked. If not, input cout no file. Return 0. All right, so this should all be familiar. And then we say while input. And again, I'm cheating a little bit here. And I need a string to store the guests. Okay, so here's what we're doing. We've declared our container class, a vector of string. Everybody good with that? We have a current guest. This is going to, as we read each guest from the file one at a time, this is going to hold the guest that we're working on, because we'll be reading one at a time. This opens the input party.text. It checks to make sure it opened correctly. Does this look familiar to you? Yep. And then we say while input, this is while we're still able to read things, we can read a line at a time. And then let's just see out really fast and make sure that we are getting what we want. All right, just check. Why is this not working? All right, so we can see I compiled. It was all working. I ran the program, and it was outputting each line we're getting from the file, so this is all working correctly. Everybody happy with this part? Now the question is, what do we do to add to keep track of all the guests? Well, the simplest way to use this vector is one of these magic classes that has methods, is just to say guests push back current guest. Now what this method does is says for this container, take pushback as push it on the end, so take it and add it to the end, the current guest. Who's with me? So this is a container. Yep, I'm going to go over it a couple times, and we'll see exactly what happens. So what this line does is, everybody's good. I've kind of gone fast on this because we should know how to read files and stuff. We're good on that part. After we've read it in, we're printing it out just to show that we've read it in correctly. And this is the new part, guests.pushback. Guest is the name of the vector that we declared. It's a container. It has a method called pushback. And pushback says take this thing, this object, current guest, and stick it on the end of the vector. So initially, when we start, the vector won't have anything in it. It'll be empty, right? Because we haven't added into it. When we create a vector, it's empty by default. Every time we push back, what it's going to do, it's going to create a new slot And it will add essentially from the top down. Does that make sense? Each time it's adding one of the things that we told it to hold. So we told this vector it was going to hold a string. The current guest is the string, which is the name of the guest we read out of the file, and it just gets slapped onto the end of the vector. So it's kind of like this. Imagine you had trying to think of something that looks like a vector. Have you ever seen those accordion files where you open them up and there's a bunch of different slots in the accordion file? Everybody know what I'm talking about, right? So you have an accordion file, you open it up. And initially, you can think of the vector just like one of these accordion files. Okay? When you're handed the accordion file, it's empty. And when you start pushing back, what it says is you say, oh, you put one in the first spot. The next time you push back, it goes in the second spot. The next time, third. And so now when you walk around, you can hold your accordion file. And if you open it up, you can see inside that you have different things put inside there. No, you're adding the newest at the bottom and the oldest is at the top. Okay, so pushback adds to the bottom. And we'll see this in just a minute. Okay. Everybody with me conceptually what we're doing here? Yes, thumbs up, thumbs down. That side of the room is in their own world today. Hi. All right. So here we are. Now we have read all, and when we're done with this, we should have read all of our guests and put them into this container called guests, which is a vector. All right. Everybody with me so far? Now, how would we know what was in there? Right? We've put things in there, and I've showed you how to put things in, but I haven't showed you how to take things out. So let's just compile this quickly and make sure it compiles. And we'll run it and make sure it runs. So we're seeing some output, but what we're seeing is output right here. We're not seeing what's currently in there. So here's what I'm going to do. I'm going to take out that output statement. And if I compile it and I run it again, there's no output because we haven't output anything. Everybody with me on that? Now what we're going to do is I'm going to show you how to look at each one of the slots inside this vector. Here's how we do this. Typically, we use a loop like this. And what we're going to loop is we're going to loop the number of times equal to the number of items that are in the vector. How do we know how many things are in the vector? Pardon? Well, we could. If we had a while loop, we might be able to have a counter that did it. Yeah. Absolutely. Here, do you want a prize for that? That's exactly what I was looking for. Sorry, I'm off today. Okay. Here's what we do. Just like when you have a string, you can ask the string how long it is. When you have a vector, you can ask the vector how long it is. If I could type the right thing. And the way you do that is use size. Now let me ask you a question. It turns out that each one of these things has a number. Each slot that is in the vector is numbered. How do you think they are numbered? Yeah, they start at 0. They start at 0. And if there are 4 things, they are numbered 0 to 4 minus 1, which is 3. Does that make sense? In computer science, we start numbering things with 0, strings and vectors. So what we're saying is start at 0, and while you are less than guess.size, which means if there are 4 items in there, there are 0, 1, 2, 3. So when you get to 4, you've gone too far. And then we say I++. So now we are looping the correct number of times, and we want to output something. Now, when you're working with these, with a vector, there's a special notation that allows you to refer to a particular slot. And what it is you say the name of the vector, then a square bracket with a number of the slot that you want out of the vector. Okay? So if this is guessed, if I was 0, if you said guessed 0, you would get the first item in the vector. If you said guess square bracket 1, you would get the second. Yes?
So, with the size, that's an operator?
This is a method. Yeah.
The size method. So why is there nothing inside the size?
Because in order to ask the vector its size, we don't have to give it any information. The vector, we don't have to say, take this input to compute with. We just say, tell me your size, and it goes, oh, I don't need an input. I just need to tell you how big I am, and it returns that. So you can, but we still need the parentheses because that's how we know it's a method. All right? So it's kind of weird. It's like a function that doesn't take any arguments, but we still need the parentheses there to show that it's a function. Size never takes any arguments. There are some other things that we'll see that do take arguments. But this is easy. Yes? Yep. So actually, yeah. So here's what happens. I kind of tried to draw this on the board. If you have a vector and it has different slots, each slot is numbered starting at 0. And the way you tell which slot you're trying to use is to put square brackets and the number of the slot after it. Okay, so you say guess square brackets and the number of slot. Now here inside this while loop, we're actually looking at each slot one step at a time. So we're going to eventually look at all the slots. Does that make sense? But after that, we can just go through and pull some out individually. So if this wasn't in the while loop, we'd have a problem because it has I. Yeah, but here, we could do, well, let me run this and I'll demonstrate it works, and then we can try a couple other things, okay? Everybody see where I'm going with this? Am I going too fast? Nod, shake your head, look bored. All right, let's just run it and see if this works. All right, it compiles and we run it, and here it printed out the same names, right, that it read before. So here's what's happened in the program is it's reading things out of the file, it's putting them into the vector by slapping them on the bottom, and then here we're looping and saying, hey, we're starting at 0, we're going through guess.size, print it out, and we're printing out all the individual names. Yes, sir? It's because I have an extra space inside my file here somehow. Or I'm doing the loop one too many times, one or the other. So I'm doing the loop once too many, I think, actually. In fact, I probably should, I don't know if I can do get line input inside there. We can try that really fast and see. Don't pay any attention to what I'm doing. Take a break, check your notes, look at your watch, check your email. I just want to check and see if this works. Yeah, that did it. So I just changed the way I was reading the loop. I was reading the loop one time too many, which is a common error if you do it wrong. So I just moved the get line inside there instead of the while input. All right, who's happy today? Who's not really happy? Who is filled with some sort of existential vacuum? No. All right. So this is an overview. This I went kind of quickly as an overview to show you that we can have these containers that we can stuff things into that we can then do other things with. So instead of having to keep track of 20 things individually, we can put them in a vector, which is a container, and we can keep track of them just as one individual unit. Kind of like if you go to buy a case of Coke, instead of buying 24 cans of Coke, you buy one pack that you can carry around. Does that make sense? And this is kind of the more advanced use of loops. The more advanced use of vectors. But this is the kind of thing that you can do with them. Does that make sense? Now, that being said, and that being kind of probably a little more complex example, let's go back and just look at a simpler example. Everybody okay with that? Yes, sir. Let's check it and see. So here I just added an output statement, and all this is going to do is print out how many people were in there. Does that make sense? I do need a semicolon. We'll compile it, we'll run it, and it says we have 6 guests, which makes sense. 1, 2, 3, 4, 5, 6. Yes? There are differences between compilers, so I'm not quite sure. I'd have to look at yours. Yes, sir. Yes. There's no debate. He just asked what it printed out, and so to show you what size was doing, I decided to print it out. Okay. All right. Let's take a little break for a second. Wiggle, shuffle, stand up. The answer is this version of the compiler does not have a for each loop. It's in the standard, but it hasn't been written into the compilers yet. Which is a shame because I've been telling you there's 4 kinds of loops. This was the 4th kind, but I just realized this morning our compiler doesn't support it. Yeah. It'll be there before too long. So. Yeah. Oh yeah, I'll put it up on Yeah. Yeah. I try to. Sometimes I forget for a day or two, but if you ever don't see something, email me and then I'll remember to put it up. So. All right. 45-second break. Reading code's not a problem? I haven't given you crazy code to look at yet. Yes? Mm-hmm. Okay, so welcome back. Do you want to go ahead and ask me your question? No, I want you to ask again so I can tell everybody. Okay, so the question was, can vectors hold values of only one type? And the answer to that question is yes. Vectors can only hold one homogeneous type. So if you have a vector, it's going to be all string, it's going to be all int, it's going to be all of something. Now, does that seem like a limitation to you? A rather annoying limitation? This limitation will become abundantly clear to you while you're doing project 3. And then in project 4, we will start working around this limitation. Okay? So right now, all the vectors are of a common type. A single type. All right, so let's talk about vectors just a little bit more gently instead of jumping into the big example. But I just wanted to show you what we could do with it. And I also wanted to show you that code because your next project, when you get around to working on project 3, is going to have a bunch of different vectors. And I wanted to give you that code as an example for when you started working on your vectors. So let's do a kind of simpler example, okay? So we're going to do pound include vector. We will create a vector of int, which we will call our example vector. Now we can just define the vector like this. What does this do? Yes? Exactly. So this creates a vector named example vector. It only holds integers. And how many things does it have in it initially? How many things does it have in there right now? 0. It always starts holding 0. And it has space for 0 items. Now some of the stuff we can do with this is if we want, we can give it an initial size. So this is kind of like this declares an empty vector. We can also tell it how much stuff we want in there if we want. So we can do, say, a vector of int which we can call example vector fixed size. And the way we tell it how many things we want is we put parentheses. We put parentheses behind it. So if this declares a vector of integers that holds nothing initially, this says this is a vector of integers and there's going to be 20 slots in there. Yes, sir? No, you do not need a period before the parentheses. It's not a method. Say again? No, it's just, this is called, well, we're about to call it, but just, it works like this. You do not need a method. This is not, the parentheses don't, oh, I see what you're saying. Okay, I understand the question now. So in the past, when we've seen parentheses, they've indicated that it's a method or a function, right? This is another use of how to use parentheses that is not a method or a function. What this is it's just an operator, essentially, that says for a vector how big it should be. Yes, it's a constructor, but we haven't really talked about constructors yet. Yeah.
So that vector, even though it does have an initial size, it's not holding anything.
Yes, exactly. This has 20 slots, and what is in those slots? I actually don't know. I don't know what's in there. Do you want to take a look and see? Okay, so do you all understand what the question is? This vector doesn't have anything in it. This vector we've created, and we've told it to have space to hold 20 things. But after we've created it, what is actually in there? Do we know? We don't know. And in fact, I don't know either. So we will create kind of our standard little loop that we will see over and over again for looking through the contents of vectors. And I'm a little bit scared to do this. All right, does that look right? So here we go, we've created the vector. This one's empty. We've created the vector that has 20 spaces for things in there. And do we know what's in those things? We sure don't. We're going to take a look and see. I have a feeling it's going to be chaos and madness. Oops. Oh, it's all zeros for some reason. Could be that we're just lucky. Sometimes it may not be all zeros. Either that or the compiler has gotten better at things. So, all right. They all happen to be zeros this time, but I wouldn't count on them always being zeros. All right. So here we declared an example. We can see that that thing has stuff in there. Let's say that we wanted to change one of the values inside that fixed size vector. How might we do that? Well, here's the thing. Once you have the type, once you have the vector declared and there are spaces, you can access any arbitrary element in there by putting these square brackets and the equal sign, and then you can use it to set values if you want. So what this says is it says here we're declaring a vector of a fixed size. It's going to have 20 slots. We're going to loop using a for loop from 0 to 19 that will access each and every one of those slots and print it out. And we ran that and we saw it was 0. Right? Now we're going to say, okay, take slot number 10, which is actually the 11th slot, because we count from 0 to 19, and set it equal to 78. And if I save this, if I compile it, if I run it, it's still going to print out all those zeros because we printed things out before we changed them. Does that make sense? But let's go ahead and let's change the value before we print it out. and see what happens. So we'll print it out, we'll run it, and you can see this element here suddenly became 78. It was item number 10, that's what we said, slot number 10, which makes it what element? The 11th element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that worked like we expected it to work. So I'll go back to the code. So you can either declare a vector with no size, or you can declare a particular vector of a certain size, and if you have something that already has size, you can access a particular element in it. Okay. Yes? That was going to be my next example. Okay? So, everybody see what's going on here? Any questions about this? So, here's what we're going to do now. We accessed element number 10 in the example vector of fixed size. Let's make example vector 10 equal to 200. Example vector is this one that's empty. How many slots does it have in it? 0. So now we're going to try and access slot number 10. What do you think is going to happen? How many of y'all think this will compile? How many of y'all aren't sure? How many of y'all think it won't? Okay, let's try and see if it compiles. It compiles, fine. The compiler is happy. What's going to happen when we run this? Is it going to be happy? Segmentation fault. Segmentation fault. When you're working with vectors, you might on occasion see something called a segmentation fault. A segmentation fault means you have tried to access an element in an array, or an element in a vector that does not exist. Okay? So if your code is running and you're working with vectors and you get a segmentation fault, it probably means that you have tried to access something that does not exist. Most commonly, people end up doing this in the loop. Like when they're looping over the vector, they will like do 1 to n instead of 0 to n minus 1 as their counter. That happens pretty often. Yep.
So where did we go wrong? Because aren't we? Oh, is it because
This one.
Not
Yep. Example vector of fixed size had 20 elements. So we said make element 10, 78. That's fine. And then after we said, hey, example vector, and we go back and look at what that was, that is an empty vector. And we said, go look at element 10 and set it to 200, and it crashed. Yeah. Let's try it. Let's try it. Let's try it. You ready? So we made it 0. We'll compile. We'll run it. Seg fault. When we declared it, when it's empty, it has 0 slots because we have not done anything. Because sometimes when we're working with vectors, we'll have a fixed number of elements, right? And we know how many there are. Other times we're working with vectors, we will have an unknown number of elements. And rather than accessing them by number to set their values, we'll use pushback instead. Okay. So you can use pushback if you don't know how big it needs to be, and you just want to make it bigger. The vector will automatically get bigger by 1 in order to accommodate what you use with pushback. Yep. You could. I mean, these when I'm explaining this, I'm kind of trying to give you a simple example about what we can do with them. Vectors are super, super commonly used, incredibly commonly used. Vectors and you'll hear them sometimes referred to as an array. Vector is the C++ style of an array. An array is like a C collection of things. Vectors are better, so that's why we teach them here. But if you ever hear an array, it looks kind of like this, but it's a bit more fragile. So you can do all sorts of things with vectors, all sorts of stuff, and all sorts of things with arrays. You can do, anybody taken like a math that has like matrix multiplication, stuff like that, incredible amounts of stuff. Robotics, 3D graphics, all use tons of arrays and vectors. This, by the way, is called a one-dimensional array because you can just add things that go down. There's actually 2-dimensional arrays where they go down and across, and 3-dimensional arrays where they go down across and come out, and you get like boxes within boxes within boxes. You can have as many dimensions as you want. So, yep. Mm-hmm. Yep. Yes, it would. You want to do that? So here's what we're going to do. We can do example vector dot push back 200, and that will work, right? And now we can do cout angle example vector square bracket 0, because we have something in there. So instead of trying to set example vector square bracket 0 to 200, I just said dot pushback. And what this will do, if the vector is empty, it will create a new space at the bottom, which, since it's also the first one is also at the top, and put a 200 in there. And now when we run this, it should not crash when we call example vector 0, because we created that space. So we should see the last thing that prints out here is that 200. Okay? Yep. Great. Yes, when you use pushback, it will put it in the bottom of the vector. It's just that when the vector is empty, the bottom is also the top. So, does that make sense? Yes, into the bottommost slot. And if there's not enough space, it will create new space for it, which is important because the C-style arrays cannot do that. Yes? You can. We'll try it in a second. Yeah. We used it in the example prior because when we're reading lines out of a file, we don't know how many we're going to get. And so I didn't, since we're reading out of a file, I didn't say make a vector of party guest of a particular size because we were just going to add them as we went along. And in fact, when you go to project 3, that's how you're going to use the vectors. As you read data out of the file, you're going to stick them in vectors so that you'll have like a big list of everything. Did that kind of answer your question? So the difference is there's a bunch of different ways to use vectors. Okay? One way is to use a vector that's empty and to use pushback to create additional space as you need it. Does that make sense? That's one way. The other way is, if you know how many things you're going to have to hold, is to create a vector of a specified size that's just big enough to use the things you want to hold, and then put them in there. Okay? So 2 different use cases. You can also mix the use cases. If you have a vector of a particular size, you can add things using pushback if you want, because it will let you do that. It just all depends. Remember, then let's just go back to like something really basic here for a second. What is an algorithm? A series of ordered steps designed to accomplish some task. What is a program? A program. What? I heard some human readable mumbling over here. So, an algorithm that a human can read and a computer can execute. Okay? So all of these data structures, whether you're using a vector or things, are just there to support your algorithm. And the way you choose which one to use is dependent on your algorithm. It's not dependent on the feature of the vector. Okay? So, if your algorithm calls for you to remember a whole bunch of stuff you're reading out of a file and you don't know how big it's going to be, you use pushback. If your algorithm is such that you know you're going to have a certain number of elements to work with, then you just make it that size and go with it. Does that make sense? Yep. You probably wouldn't. You can. The language is structured to let you do what you want, but what you want to do depends on the algorithm you're doing. Is there an algorithm where you have a fixed size vector where you want to push something on the back? Probably. Can I think of it on the spot right here? No? So, yep. Sure. So here, I'm going to do something here. I'm going to make our example vector a little bit smaller because it's kind of big right now. Let's make it only 5 things. And let's set this one to 78, okay? So I've made our vector a little bit smaller because 20 was a little bit ambitious. So if we print it out, whoa, wait a minute. Oh, I didn't save it. No wonder. All right. So these 5 things, 1, 2, 3, 4, 5, are in our fixed size vector. We saw that we set 1 to 78, and this is 200 down there, right? I'm going to add a little bit of printout to make it clearer what we're doing. Okay, so we have our fixed size vector and our not fixed size vector. Let's just look and see what happens when these things print out. So our fixed size vector has 1, 2, 3, 4, 5 values. We happen to set one of them to 78. Everybody good with that? And our not fixed size vector, we pushed 200 onto the end. Okay. Now, the question is, what happens with the fixed size vector if you do pushback? It gets bigger. Okay. And let me show you. So here is our example vector of fixed size 5, and we set element 1 to 78. Now what we're going to do is we're going to mess with it, and we're going to make it a bigger size. And in your honor, what number would you like to push in there? Quick, name an integer. 7. Good choice. Okay. So now we had our vector. It was fixed sized. It had 5 elements. We set element in slot 1, which is the second element, to 78, and we did pushback 7. How big is this vector now? 5 plus 1 is, so we should see 6 elements there. And when we run it, now we'll see fixed size vector, 1, 2, 3, 4, 5, 6 elements, which the last one was the 7 that we pushed onto the bottom, and our not fixed size vector also has something on there. All right, everybody good with that? So these are the 2 ways that you can put things into vectors. The way that you look at what's in the vector is using these square brackets. Okay. Everybody good? Other questions? Things to try, experiments? If not, I will tell you some other stuff. So, beyond angle brackets, if you want, you can also use @. You can also use @.at method. The .at method is exactly the same as the square brackets. It's just another way of doing it. It's a synonym. It's kind of like, oh, hang on a sec. Don't let me steer you wrong. This one might have a different term. It might be element @. Let me just check this for a sec. Yep, okay. @ works. So these 2 are synonyms, right? Like synonyms in English, like, I don't know, 2 words that have the same meaning that are different. Okay, that's one way. You already know about size, right? What does size do? It's a method that tells you the size. We can have something that tells you if the vector is empty or not. So we can say if, example, vector dot empty. What do you think empty does if you spell it right? Yeah, it pretty much just tells you if the size is 0 or not. But it returns a Boolean, and I'm missing a parentheses, that's why. So you can use .empty to check and see if a vector is empty or not, and it should tell you Boolean-wise whether it is or not. Oh, it would help if I didn't have end. How about end L? And we run it, and it says vector was not empty because there was at least one element in there. That's most of what you need to do with vectors, actually. One other thing that we need to do. There is a clear method. Example vector dot clear. Anybody want to guess what clear does? What does it mean to clear it? It empties it out. So before we ran and we saw that the vector was not empty, and I put this example vector dot clear in front of that. So what should we see now? That it is empty. It should be empty now. And it says vector was empty. Yep. There is a way to clear individual lines out there, but I don't really want to go into it because it's probably like delete or something. We don't really use it in this class. If you go online, if you want it, you can just I seem to have internet today. So you can just look up like the C++ vector class. Chrome, where are you? And this reference is pretty good. Stop it. And this will show you all of the different things that you can do. And it actually has way more details than you need. So here are all the things it can do. Begin, end, this is iterators, which we're not going to talk about. Capacity, size, max size, resize, capacity, empty, reserve, shrink to fit. It does a lot of stuff. But the stuff that I've shown you is essentially what you need for the project. Okay? And if you ever want to learn more about it, you can go look at this. There's push back, and then there's pop back. Push back will put it on, pop back will take the last thing off and return it. You can insert, you can erase elements, you can do all sorts of stuff. So you can look at this if you want to see more you can do, but what I've shown you today is essentially what you will need. Yep. Let's ask it and see. So here we cleared the vector, but we didn't see if it reduced all the slots. Let's see if it. So the question was, after you clear it, what is the size of the vector? That is, does it reduce the size to 0, or does it just empty out the slots? What do you all think? Empty slots, reduce size to 0. You could look at the manual, or you could just run a little test and see. Size is 0. So it deleted all the slots on there as well. Yes, sir. Code? I'll post this so you can look at it. Yes?
Are there advantages or disadvantages of using a vector iterator as opposed to the square brackets, or they basically just do the same thing?
Vector iterators do not exist outside the web page that I just showed you for this class. So I'm not going to teach you all iterators. You'll get them later. So an iterator is a different way to go through the vector, and it's a little bit more complicated. So it's not part of this class. Other questions? Yes, sir. Is there any way to never mind? All right. Anything else? Yes, sir. No. So that's an excellent question. One of the things we might have is a function that takes a vector as an argument. How about we write one of those right now? And in fact, how about we write a really useful one that I almost always end up using myself whenever I have a thing? Let's write a thing that's called all right, do you want it to return a vector, or do you want it to take a vector as an argument? All right, let's not return one right away. How about this? How about we'll do it quickly if we have time. how about we just create a function that takes one as an argument? All right. Printing a vector is something that we do commonly when we want to look and see what's going on inside our vector. So what I've done here is I've created a function prototype that says void print vector. What is void? Oh yeah, I'm missing an angle bracket. No wonder. Thank you. Okay. What does this function return? It does not return anything, which means that it doesn't have to do any computation, that it returns a value. It just does something or prints something out. Print vector is the name of the function. What do you think this function is going to do? It's a good guess. And what argument does it take? A vector of integers. And is this a value or a reference parameter? It's a value parameter. Okay. Now, let me ask you a question about this. Do we want this to be a value parameter? How big is this vector going to be? And could it be huge? And if it's huge, do you want to copy it? What do you want to do instead? What we really want to do is that. This is exactly the case where you want to use a constant reference parameter, because you're passing something in. Okay, so down here is our function declaration, print vector, const vector of int, which is a reference parameter, and its name is the vector. All right, how do we print a vector? How do we print all the elements in a vector? It has a number of elements. We want to look at each one individually, so we use a for loop. And this is going to be second nature to you after a while. We start at 0, and what do we go to? We go from I to 0 up to, while it's less than the vector.size, I++. And what are we going to output here? The vector, and we can either use square brackets or .at. Which one do you all want to use? Square brackets, that's what most people use. And this should print out our vector. Okay. Now what we can do is up here, we can actually replace our output here. Example vector fixed sized. We can just replace all the code we had to print out with this function call. Everybody good with that? Sure. Yep, absolutely. All right, I'll come back to this in a sec. Let me just make sure it compiles. It does. I'll run it, and it should look much like it did before because we've just moved the code that prints around into a function. Okay. All right, everybody good with that? Yes? Straightforward? Confusing? Who needs a piece of candy? Yes? What? Do you have a question? What is it?
No, I don't.
Okay. All right. Yes? This is just the name of the vector. Just as a variable name? No. This is a parameter in the function. And a function, the parameter in a function only has to be defined in the parameter list. Okay? So if we... just give me a second to figure out how to explain this. So here's what happens. I'm going to split the screen into two so we can see the function call at the same time we see where it's called from. So here, right here, this is where we're calling that vector. What we're calling the function. So we say print vector, and we give it the name of the vector that we want. And the name of the vector we want is example vector fixed size. And when the function call happens, this gets essentially copied here. Remember when we talked about the different things? So even though this has a name up here, the local name down here is called the vector. And so I didn't use one of the names up here. I just said this is the vector that we want to print, so I called it the vector. If we could also, if we wanted, call, down here we could say print vector example vector. And instead of the fixed size vector being used, it would use this other one instead. And it copies it over, just like when we talked about the functions and how things get copied over before. Yes, sir. No, we don't need a comma here because there's only one parameter. The only parameter here is the one that we've named the vector. It's just that defining what type it is really complicated, right? Because it's const, it's a vector, it contains ints, and it's a reference. Yep. We are using a reference here because when you're moving big pieces of data around, copying it can be very slow, right? This vector we know is very small, but remember we were talking about what happens if you're the NSA and you have 1 billion call records? Say we wanted to print out the 1 billion call records. If we copied 1 billion things from the main function down to this, it would take a long time. If we do it by reference, it's much faster. The problem is that if we do it by reference, some programmer who's programming this down here might screw up and change something, and we don't want that to happen. So this is just kind of how most people do it.